Ignition sequence start.
Good morning, and welcome to this view of the activity in the International Space Station Flight Control Room at NASA's Johnson Space Center. These specialists are keeping an eye on the operation of all of the space station systems and helping the Expedition 66 crew members through the last few hours of their work week in space. The American and German crew members have focused this week on science experiments and cargo operations, while Commander Anton Shkaplerov and Flight Engineer Pyotr Dubrov completed a spacewalk of more than 7 hours to outfit the station's newest module.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Nilofer Ramji. A spacewalk, cargo dragon's departure, and science investigations. It continues to be a busy week aboard the space station. On Wednesday, January 19th, Russian cosmonauts Anton Shkaplerov and Pyotr Dubrov completed a spacewalk to outfit and configure the Prichel and Noka modules. The duo installed new handrails, rendezvous antennas, a television camera, and docking targets on Prichel. A Soyuz spacecraft carrying 3 Russian cosmonauts who will be part of the Expedition 67 crew is the first scheduled docking to Prichel planned for March. Cargo Dragon is set to return to Earth carrying more than 4,900 pounds of supplies and scientific samples. The SpaceX Cargo Dragon has been packed with samples from experiments conducted aboard the orbiting laboratory and is ready to depart the space station. You can catch all the action on NASA television, the agency's website, and the NASA app. After re-entering the Earth's atmosphere, the spacecraft is scheduled to splash down off the coast of Florida. One of the payloads returning aboard Cargo Dragon is the In-Space 4 physics study. Results from In-Space 4 could share insight into harnessing neoparticles to fabricate and manufacture new materials, including medical diagnostics and thermal shields for Earth and space applications. The combustion experiment Acme Flame Design had some progress this week. The Advanced Combustion via Microgravity Experiments, or ACME, is a suite of 6 combustion investigations aimed at reducing pollutant emissions in practical terrestrial combustion and strengthening fire prevention in spacecraft. One of the experiments, Flame Design, aims to improve our understanding of soot inception and control to enable optimization of oxygen-enriched combustion and design of non-premixed flames that are both robust and soot-free. That's Space to Ground for this week. Thanks so much for watching. Don't forget to follow @ISS_research on Twitter to keep track of all of the science aboard the space station. We'll see you next week.
One more note on the subject of extravehicular activities. NASA is working to return astronauts to the moon in just a few years to explore it and learn to live there long term. It's part of the plan to get humans ready to explore out into the solar system. It's called the Artemis program, and Artemis teams here in Houston have used the Neutral Buoyancy Laboratory to work on developing the tools and training plans for the astronauts who will conduct the moonwalks of the future. Take a look. Long-duration missions on the International Space Station are helping prepare astronauts to live on the moon. And flight engineer Mark Vande Hei is now in the last couple of months of what's expected to become the longest single spaceflight ever by an American astronaut. Before he launched last year, knowing that there was a chance he'd be making an extended trip, the retired U.S. Army colonel was looking forward to another shot at some of the things he knew he was going to get to experience once again.
always, as a kid, I never would have told anybody that I wanted to be an astronaut. My attitude about that was like saying, I want to be Spider-Man or I want to be a superhero. I always thought that working at NASA would be amazing because my physics background, the photography you see from space, and the knowledge that we're kind of pushing the limits with our space program. All those things made NASA seem very appealing to me. The fact that I got to be an astronaut is gravy. And now my attitude about actually being an astronaut, actually getting to go to space, that's all just, I keep getting these bonus deals that are even better and better. So I'm pretty excited about it. The thing about physics that I really like is it takes what we know, figures out a mathematical model for it, and then you can use that to try to get to what we don't know and theorize about things. It helps us imagine things that we can't even sometimes use instruments yet to detect, and then science follows up with that to try to do experiments and try to test theories we come up with. So certainly being able to contribute to science, the space station's all about science, and it's helping NASA further our exploration goals. I really think we have to keep exploring. Most of our nation's background involves people leaving what they were comfortable with and coming to a place that was new and different and very risky. So I think it's part of our national character to want to explore. Dedicating those resources to this peaceful endeavor that can actually help out all of humanity. My name is Mark Vandehei, and I'm a NASA astronaut.
Those who see the Earth from the International Space Station often say it provides them with a new appreciation for the planet. Well, many of the pictures that they take of that planet are also providing the raw materials for science experiments. The Avian Migration Aerial Surface Space Project takes advantage of thousands of images captured by astronauts to give people an understanding of the migrations that birds undertake across the Earth.
I flew as a Canadian astronaut on the mission STS-42, Space Shuttle Discovery, back in January of 1992. Currently, my role as president of the foundation that bears my name is to conduct some research into the migratory corridor, habitats, and behaviors of certain species of migratory birds. We've been trying to utilize photography to put together a compelling reason why people need to pay attention to these very fragile organisms and their fragile environments. We think that doing it at 3 different levels, the aerial, surface, and space, will provide the different perspective. So it's as if we were down at carpet level with a magnifying glass on the surface, and then we get up and we see the patterns a little bit differently. And then we get into space and see this whole corridor, but we see different patterns that we didn't even know existed. So the space station can provide us these images so we can actually construct part of that flight, a part of that corridor of one of these species.
Growing up as a Canadian, Dr. Bundar was one of my heroes. She was the first female astronaut that we had in Canada, and I always kind of looked up to her because she was also a scientist and a physician. And there she was offering me the chance to participate in this beautiful project. And I loved because it fit with my hopes of sharing from space station my love of the environment. One of the challenges of taking photos of the Earth from space station is that we're going pretty fast. You know, we're going around the world in about an hour and a half, flying at 5 miles a second. And as you get to the cupola, get your camera ready, you're looking at previous images, satellite imagery, trying to wrap your mind around what you're trying to see. And then you look forward towards, the limb of the Earth as the Earth the scene is coming towards you. It's coming pretty fast. And you gotta identify it on the horizon as it approaches, because you have maybe just a few seconds as you're flying over that location. And then you look back and maybe you have a few more chances as you're flying away from it, but that's it. The whole thing lasts, way less than a minute. But kind of chasing the right frame is a bit of an art because you only have one chance.
To date, we have at least, I'd say, somewhere between 25,000 images provided to us from NASA.
This was one of the larger imagery projects that we've worked on. Typically, we work with researchers or scientists that are looking at a few different locations on Earth, maybe no more than 10. And this ended up being about 50 different locations on Earth that we wanted both nadir looking shots, which is a straight down looking shot, as well as Earth limb shots. We worked with various crew members over the years to take a lot of these photos, but we also reached back into our database of over 4 million astronaut photos just to see what already existed. We get excited when external groups seek out these types of imagery projects with us, especially scientific and research groups.
Space exploration really offers us an amazing perspective on our home. And I think this project is a beautiful example of how we can kind of scratch our heads, take a few steps back, look at the big picture.
It's about taking that creativity that were offered in space, combining that with the aerial shots of getting closer and closer to when they put their feet on the ground, to me is an extraordinary way of trying to bring together this emotional story of the importance of habitat protection so that these beautiful, magnificent creatures that fly the way we do in space can survive on our planet for future generations.
Astronauts and cosmonauts on the International Space Station spend some of their time keeping the station operating smoothly, some of their time supporting science operations, and sometimes they help students on Earth learning about science, technology, engineering, and math. In this demonstrations video, astronauts Megan MacArthur and Shane Kimbrough use the weightless environment on the station to demonstrate the concept of moment of inertia in a way that even I can understand it.
Hello, my name is Megan MacArthur.
And my name is Shane Kimbrough. We are living and working aboard the International Space Station orbiting 250 miles above your head. Here on station, we live in a microgravity environment which allows us to experiment with weightlessness and push the boundaries of science.
Today, we will demonstrate moment of inertia by first using a large flashlight, then demonstrating it with the human body. Are you ready? Let's go check it out. Inertia is the tendency of an object to resist change in its current state of motion. That might sound familiar since Newton's first law of motion is also referred to as the law of inertia. Moment of inertia, on the other hand, describes an object's tendency to resist rotational acceleration. An object's moment of inertia is a property that depends on how mass is distributed around its axis of rotation. There is a relationship between an object's mass distribution and how easily it spins or resists spinning. In general, objects have a lower moment of inertia and are easier to spin if the mass is closer to the axis of rotation. As you can see, the flashlight rotating about its longer axis is spinning at a faster rate than the flashlight rotating about its shorter axis. This is because its mass is closer to the axis of rotation. The spinning flashlight in this position has a lower moment of inertia, which means there is less resistance to rotation. When the flashlight is spun about its shorter axis, its mass is spread further away from the axis of rotation. In this position, the flashlight has a higher moment of inertia. Now let's see if this applies to humans as well.
Notice how fast Megan is spinning in relation to her body's position. When her arms are tucked in tightly next to her body, her moment of inertia decreases, which causes her to spin faster. When her arms are extended out, more mass is pulled further away from the axis of rotation, which increases her moment of inertia and causes her to spin slower. This happens because redistributing our mass changes our moment of inertia, which in turn changes how fast we spin. Thanks for coming aboard and watching our demonstration today. To explore more on moment of inertia, check out the Classroom Connection lesson that goes along with this video and discover many other lessons and activities at the STEM on Station website. See you next time.
The mission of the International Space Station includes serving as a platform for scientific research and for learning how to support human crew members during long-duration missions away from the safety of Earth, and promoting international cooperation, and being a test bed for future technologies that we'll need to support our plans to explore farther than ever before in the years to come.
Making space for technology development. Presented by Science at NASA. The International Space Station, or ISS, is Earth's only orbiting laboratory. That's important because it not only allows us to conduct research that benefits all of us on Earth, it also provides the only microgravity environment in which we can test technologies critical to our deep space exploration in the near and far-term future. Here, engineering models can be validated, and new technologies and systems for future missions can be demonstrated, without risk to crew members. Historically, the Mercury program enabled the Gemini program, which in turn enabled the Apollo program through technology and systems advancements. Today, the space station is giving us a similar experience in long-duration spacecraft operations and serving as a testbed for new technologies and upgraded vehicle systems, which are enabling future missions. Dave Horniak is NASA's ISS Technology Demonstration Research Portfolio Manager. He notes the ISS lets us demonstrate that a technology works as intended in a spacecraft environment. Demonstrations on the space station inform operators and flight crews how the system operates, proves interoperability with other systems, and demonstrates system safety and reliability. There are many technologies and capabilities that need to be developed as we move forward to the Moon and onto Mars. For example, researchers have recently tested a new design of solar array that will be used on the first module for the Deep Space Gateway, our future space station that will serve as a home base for astronaut expeditions to the Moon. Solar arrays in operation right now need to unfold before becoming active. But new designs allow future solar arrays to roll out and also retract. They were tested for strength and durability on the ISS and were designed to be more compact than current rigid panels. NASA's Orion multipurpose crew vehicle is a 4-person exploration craft designed to take astronauts farther in space than anyone has gone before. Its backup navigation system uses a new technology that is optically based. It captures images of the Moon or Earth, and based on their size and angle, an algorithm determines Orion's location. These optics can't be tested on Earth because our atmosphere would distort the images enough to make the algorithm inaccurate. Aboard the ISS, however, the algorithm was confirmed to work properly. A secondary benefit is the system was tested at spacecraft speed, making for a realistic navigation scenario. As people travel deeper into space, they'll need solutions to a variety of safety challenges. For instance, if a fire breaks out, how fast can it grow and spread in a microgravity environment? NASA's Spacecraft Fire Safety, or SAFFIRE program, has already conducted a series of experiments on 3 ISS cargo vehicles to measure flame growth, oxygen use, and combustion products. Results are helping to improve spacecraft fire detection, response and extinguishment, and crew protection. Ultimately, says Horniak, technology and operations demonstrations occurring on the ISS today are guiding our planning, reducing risk, and providing capabilities to enable future exploration missions. For more inside information about the tech being tested aboard the station, visit www.nasa.gov/ISS-science. For more on the science of space exploration, visit science.nasa.gov.
One goal of the International Space Station is to develop the technologies we'll need for future explorations, for when we go back to the Moon and then on to Mars. NASA's Exploration and In-Space Services Projects Division at the Goddard Space Flight Center has sent many such projects to orbit. In this episode of Tech on Deck, we learn about their first one, the Robotic Refueling Mission.
Outside of the International Space Station, space can be a lonely place. Most satellites are designed to live their lives alone, and we've yet to find life outside of Earth. This means that when we launch a spacecraft or satellite, for the most part it's on its own, and has a limited lifespan based on when critical items like fuel run out, or something breaks. You wouldn't throw away your car if it ran out of gas, and thanks to the advent of modern-day robotics, software, and computing power, we will soon be able to apply that logic to satellites. We are on the cusp of breaking the one-and-done paradigm that exists for most satellites. An important step in that direction is NASA's Robotic Refueling Mission, or RRM, demonstration on the International Space Station. Because refueling a satellite that was not designed to be refueled has never been done before, practice is key. With that in mind, the first 2 phases of RRM took place on station from 2011 to 2017 and tested the tools, technologies, and techniques to refuel and repair satellites in orbit.
RRM and RRM Phase 2 were designed to demonstrate end-to-end refueling of a spacecraft, as well as the first steps of cryogenic refueling or replenishment. We wanted to use the robot on the International Space Station to be able to demonstrate the technologies and techniques to do this refueling, so we built innovative tools to bridge the gap between the robot and the payload interfaces.
Consisting of a module or box affixed to the outside of station and robotic tools, the demonstrations use station's Dexter robot to operate tools and test servicing tasks such as cutting and peeling back protective thermal blankets, unscrewing caps, turning valves, transferring fluid, inspection, and intermediary steps leading up to refueling.
Once we were all done, we were able to transfer fuel end-to-end through a spacecraft fill and drain valve that wasn't designed to be robotically refueled.
The RRM demonstration helped test and prove technologies that will make refueling satellites not designed to be refueled possible, something that will be further demonstrated by NASA's On-Orbit Servicing, Assembly, and Manufacturing 1 mission. But it also helped to lay the groundwork for designing future satellites in a way to make them more easily serviceable.
These missions were important because we needed to demonstrate in orbit that this technology was ready. There were a lot of people that felt that at the time of RRM that the technology was so far in the future that they didn't feel what we were talking about was possible. So we needed to demonstrate in orbit this technology so that we could start changing the paradigm and incorporate these technologies into the future spacecraft designs and missions.
RRM Phase 1 and 2 were all about preparing an interface for refueling, which in many ways is half the battle. To robotically refuel a satellite, you need to perform a series of highly dexterous tasks to even access the valve. The next step is to actually perform refueling tasks, which is what the next phase, RRM3, has been demonstrating on station over a series of operations since 2018. RRM is a critical piece of the sustainable spaceflight puzzle that helps us with the ability to robotically refuel, repair, and maintain satellites in both near and distant orbits, well beyond the reach of where humans can go today.
As we travel farther into space, from low Earth orbit to the Moon, to Mars, maybe someday beyond that, clever solutions to supply problems, like stocking spare parts, will be a vital part of NASA's preparations. 3D printing is an emerging technology that may be used to create custom mission-critical parts. But in order for it to be practical, we first have to understand how particle shape, size, and distribution affect the manufacturing process when in the conditions found in deep space. One particular study is helping to explore those factors.
One of the things they're going to have to do for space exploration is do additive manufacturing, because we may have an engine part that fails, and you're certainly not going to take up spare engine parts. You're going to have to manufacture them there. And a lot of what we want to do with that means looking at microscopic particles, because they're building blocks. And now I think a big part of the future in this field, and for lots of different reasons, is active materials. So now we have ways that instead of just the particles being just particles. We can activate them, we can functionalize them, we can get them to associate with one another specifically. So one of the things we're aiming for is active self-replication, evolution in microgravity, to put lots of things together and to optimize properties using evolutionary processes from not living things, but mimicking what living things have done so successfully. We'll learn how to do that on Earth eventually. But before we do that, it's much better, because they have different densities, to do it in microgravity. It's always really important to do something at the forefront of science that will then become a forefront in engineering and production.
If you want another look at any of the stories we showed you today, go over to YouTube or Facebook at those addresses right there. You'll find them all, along with lots of other great features on a wide variety of NASA topics. If you're looking for good conversation about human spaceflight, check out Houston We Have a Podcast, our weekly show about all aspects of human spaceflight and NASA's missions of exploration. Today, Gary Jordan gets into the details of the one biological experiment that will fly on the Artemis 1 mission this year, which will focus on the effects of radiation on a biological sample in deep space, the first experiment like it since the Apollo years. Go to nasa.gov/podcast for this week's episode and all the previous episodes. In fact, the full library of all the NASA podcasts are there and on Apple Podcasts, Google Podcasts, and SoundCloud. You can get the latest from all over NASA delivered to you every week. Go to nasa.gov/subscribe to sign up for the NASA newsletter.